Hey everybody, welcome to chapter 1.9. We're going to be talking about inequalities. Today what this is going to be discussing is going to be an intro. Nothing that you're going to be tested on, but I do want you to get your feet wet a little bit with inequalities, just so you've seen them before you hit algebra, and that it's not a foreign language to you. And I know I can say, hey, you've done that before. All right, so we're going to be talking about inequality. We are going to be graphing inequalities today. So it's going to be very similar to one-step equations, except this time we're just going to take that a little bit further. So first thing, what is an inequality? Please pause now and write this down so you know this. All right, an inequality is something that compares two quantities. Normally, we see equal signs in between two true equations, but this is comparing two two quantities. That's saying, you know what, one thing is bigger than the other thing, or one thing is less than the other thing. Get used to using these symbols with these words. Okay, no more are we going to be talking about alligators eating numbers, or Pac-Man eating numbers, or something chomping on another one. Now that we're in pre-algebra, we're going to be using the terms of less than, greater than, less than or equal to, or greater than or equal to. It doesn't matter to me how you remember it, but I do want you to use those vocab words as you will be using those in the future, strictly in the future. Okay, so let's get moving. So the very first thing is I want you to compare these two sets. This box is actually supposed to be right here, and here, and here, and here. So you're comparing those four. Don't worry about that cream box. It's just supposed to be a little slid over to the left. So I apologize for that. But try these out. All right, so the very first one, we have 23 minus 14 and 6 on the other side. Very first thing I have to do is solve. 23 minus 14 is 9. We have 9. We have 6. Which one's bigger? 9 is greater than 6. Next one, 19 minus 3. 19 minus 3 is 16. On the right side, we still have 17. What is our answer? It is less than. 16 is less than 17. 50 times 12 and 70 on the other side. We're comparing. 5 times 12 is 60. And on the right side, we have 70. 60 and 70. Which one's bigger? 70 is bigger. Which means our answer is less than. Ooh. Last but not least, we have 4 times 15, which is, hey, look at that. We have another 60. This time we have 60 and 50. 60 and 50. So, which one is larger? 60 is larger, which means we have a greater than symbol. So it goes greater than, less than, greater than. Hoo, ha, ooh, ha, done. Now we're going to be talking about algebraic inequalities and a solution set. So, pause this video, write this down, and I will explain. Alright, so if you look at this, an inequality that contains a variable. So now we're going to get into inequalities like x is less than 7, or y is greater or equal to 19. Okay, we're going to be writing those answers down. Now, there's something called a solution set. This is the set of all solutions. So if I give you something like x is less than 7, that's not just x, remember, is just referring to any number. So that what is a number less than 7? It could be 6, it could be 5, it could be negative 437. I don't know, but we just need to know all of the numbers less than 7. So think about a number less than 7 that could be put in there. Yeah, I bet you there's an infinite number of possibilities. You could have picked 6.9999999999999999999 and still be true. Okay, there's an infinite number of possibilities. So that solution set, I'm gonna show you a way to graph that. All right. So This is very important. I do want you to actually write this down. So there's supposed to be a yellow bar up here. Hold on a second. Look at that yellow bar. Woohoo, yellow, 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 yellow bar. Sunshine on a cloudy day. That brings sunshine to your day. So I want you to write that down because it is very, very, very important. So pause now, write it down. So an open circle means that the corresponding value is not a solution. A solid circle means that the value is part of the solution. Okay, and one thing that you should add, what this means is an open circle, you're going to use that for greater than or less than symbols, and a solid circle for greater than or equal to and less than or equal to. Now I'm going to explain that in just a second, but I want you to be able to have those symbols down. So know those symbols and know if it's going to be an open or a closed circle. Okay? What in the world are we talking about? Okay, so the word phrase is x is less than 5. We know x is going to be less than 5. So what does that mean our solutions can be? Well, that means we can have multiple solutions, right? If x is just going to be less than 5, we need to pick a number that's less than 5. So a few sample solutions down here. Again, you do not need to write this down. If x is 4 less than 5? Absolutely. Okay, if x is 2.1, is 2.1 less than 5? Absolutely. What you're going to see down below is going to be that solution set. What that solution set tells me is going to be all of the numbers. It's going to include all of the numbers that are included in this solution. So what can be included in this phrase or this inequality of x is less than 5? Well, you can take any number less than 5. So any one of your negatives can all be plugged in there. 4.9 can be put in there. 4.999 can be put in there. Okay, so what this allows me to do is I put an open dot at 5. Okay, I'm going to put an open dot at 5, and then I'm shading everything to the left of 5. Now, the reason why I choose an open dot at 5 is because 5 is not included. I need a number less than 5. So that open allows for a hole in the graph. And again, I'm on a number line. Okay, and remember, as we go left, our numbers get smaller. It gets less as we go left. So I'm put an open dot at 5, and I shade to the left, as you can see by that red arrow, because all of the solutions that make this inequality true are less than 5. So everything to the left of 5, not including 5. Okay, similarly on the other, if I give you a greater than symbol, a is greater than 0, here we are at 0. Again, notice the open dot. Okay, if I need a number bigger than 0, okay, it could be 1, 2, 3, it could be 99, it could be 157,362. Okay, what it means is that red arrow, as you can see, is pointing to the right here on our graph. It's because everything to the right side of 0 is included in our solution set. However, notice I have a 0, or sorry, not 0, an open dot at 0. That's because 0 is not a solution. Now, 0.0000001 is a solution, and my graph explains that, but it tells me that exactly at that point 0, where my numbers start crossing 0, 0 is not a solution to this set, because 0, I cannot tell you 0 is greater than 0. That is untrue. It's impossible. So we need to use an open dot on our number graph to show that. All right? Convert with less than or equal to, or even greater than or equal to, we use a closed dot. See, this is where it says y is less than or equal to 2. 2 is included in our solution set, so we used a closed dot. Remember on our number line, when you were given a number line of 0, 1, 2, 3, -1, -2, and I said graph, let's say graph 2 on a number line, all right, you would put a closed dot, because that means if I graph 2, 2 is a solution. That solution right here tells me that that's true, that is number 2. Well, on this graph, it is telling me that 2 is included in my solution set. An open dot just says it is not included. A closed dot says it is included. Because if I plug in a 2 for 2 is less than or equal to 2, is 2 less than or equal to 2? Yeah. Okay, remember, yes it is. 2 is equal to 2. And all I'm asking you is 2 less than or is it equal to? So one or the other. Last one, here's greater than or equal to. Again, the same idea here. Just know that 3 is greater than or equal to 3. It's included in the solution set. That is why I use a closed dot. All right. I'm going to show you an example here that I want you to write down, and then I'm going to let you do a few on your own. All right. So the very first thing, it says most inequalities can be solved the same way equations are solved. We are using inverse operations of the inequality. Now, if you look at x plus 3 is equal to 4, we would subtract 3 from both sides to get our answer, and x would be equal to 1. Okay, that's the exact same thing, exact same way as we would have an inequality. X plus 3 is greater than 4. You subtract 3 on both sides. Sorry, that's supposed to be a 4, not a 1. Subtract 3 on both sides, and x is greater than 1. Okay, it's the exact same way. We do the exact same thing we did when we started dealing with one-step equations from chapter 1. All right, now the key is, we're going to learn this in the next chapter, but there are special rules when multiplying or dividing by a negative number. We're going to learn about that later on, but I just want you to I want to show you very first on one-step equations. So we're going to solve and graph this inequality. All right, you don't have to pause it. I want to show you it, and then I'm going to have you do this by yourself. Now, if you look at this, so we have x plus 2 is greater than 8. Again, because this is an inequality, we still solve this the same way we would solve as if it was x plus 2 is equal to 8. Now, how do we do that? All right, well, we take the inverse operation of what's happening to that 2. What's the inverse operation of addition? It is subtraction. Okay, so we take x is now going to be greater than 6. I took the inverse operation here to solve my answer. So now I have x is greater than 6. Now I need to do the second part of this question, which is graph the inequality. So I have my number line, and I always do 0, and I like 3 points on this graph. Okay, I want 3 points on a graph automatically, and a lot of times I use the number and its opposite. The question is going to be, is 6 going to be a solution? Okay, in other words, is 6 greater than 6? No, it's not. That's impossible. We can't have that happen. So because of that, we use an open dot at 6, because 6 cannot be included. It cannot be a closed dot. And we need to be bigger than 6. So what's a number bigger than 6? Well, 7, 8, 9, 10. Numbers bigger than 6, is it going to be to the right or to the left? So I'm shading to the right. And I just make sure I have an arrow here as my shade. Okay? So you can see that. I have an arrow shaded to the right, and my answer looks exactly like that. I use this graph, I use this problem, solve it just like I would in a regular one-step equation, and then I graph it in the end. Again, 3 points on the graph, 3 points on the graph, and those were my 6, 0, and negative 6. I graph it with an open dot because of my sign here, and then I shade to the right because it's telling me bigger than 6. All right? So I'm going to have you try the next few. Here's one I'd like you to try by yourself, and then I believe there's 2 more and then we will go from there. So solve this just like you would a regular one-step equation, and then see if you can figure out how to graph. Okay, if you're not quite sure, I'm going to have you pause it and I'll show you. But pause now, try to see if you can get this one. All right, so if you look at this, w minus 1 is less than 8. We need to add 1 to both sides, because that's how we would solve a regular equation. So w is less than 9. Okay, I go to my graph. Number line, add 0, and I'm going to plug in 3 points of negative 9, 0, 9. And now, is 9 less than 9? No, that's not true. Okay, so we can't use it as a solution. So we have an open dot at 9 because it is not included in our solution set because 9 is not less than 9. Now, how do we shade to less than? Well, what's less than 9? 0 is less than 9, so we need to shade towards 0. Okay, and I just draw an arrow like that. Shade it to the left because that is including everything to the left of 9. Everything to the left of 9. Including 8, 7, 6, 5, 4, 3, 2, 1, and negative 8, negative 9, negative 10. All of those numbers are included in this solution. Okay, so again, I solve it as a one-step equation. Graph my dot first. I graph my dot because we have a less than symbol shaded to the left. Okay, be careful because now we have less than or equal to and greater than or equal to. So try to think of the dot you are going to put in your solution. So I want you to give these two a shot. Pause now and try them. All right, so if you do this problem, k plus 9 is less than 12, less than or equal to 12. So one-step equations means I subtract 9 on each side. So I have k is less than or equal to 3. So on my graph, I have 0, 3, negative 3. Okay, is this going to be an open or closed dot? Well, let's try it. Is 3 less than or equal to 3? Yeah, it is. So because that's true, I use a closed dot at 3. Closed dot. And am I shading to the left or to the right? Well, because we have a less than or equal to sign, we need to shade everything to the left, to the left. Everybody do your shades to the left. You shade it to the left, to the left, to the left, to the left, left, left. Okay, we need to shade it to the left because all of our solutions are on the left. Next, 3n is greater than or equal to a negative 15. Okay, we're going to divide here by 3. Divide by 3. N is greater than or equal to a negative 5. Okay, on our graph, we put 3 points. We look at negative 5. Open or closed dot? Well, is negative 5 greater than or equal to negative 5? Yeah, it's equal to, absolutely. So whenever that's true, we put a closed dot. Which way do we shade to get bigger? To the right, to the right, to the right, right, right. And if you shaded to the right, you are right. You are correct. Okay, so again, I shaded to the right because all of my solutions are included in that. Okay, that's all I have for you today. I hope you enjoyed this lesson, and I will see you tomorrow. Bye! Ooh, and I forgot to remember, if you have any questions, please let me know when I see you next. All right? Bye!